through something called Coulomb's law. Imagine two tiny charged balls. If both balls carry the same sign of charge, either both positive or both negative, they push each other away. That's repulsion. If they have opposite signs, one positive and one negative, they pull toward each other. That's attraction. The size of this force depends on two things: the amount of charge on each ball and the distance between them. Through experiments, Coulomb found two rules. First, the force is directly proportional to the product of the charges. This means bigger charges create a bigger force. Second, the force is inversely proportional to the square of the distance between them. This means if you increase the distance, the force quickly becomes smaller. In symbols, we write F is proportional to Q1 times Q2 divided by R squared. To turn this proportionality into an equation, we introduce a constant K. The full equation becomes F equals K multiplied by Q1 times Q2 divided by R squared. Here, F is the force in newtons, Q1 and Q2 are the charges in coulombs, R is the distance in meters, and K is Coulomb's constant. In free space, the value of K is 9 times 10 to the power 9 Newton-meter squared per Coulomb squared. Instead of writing K, physicists prefer to use the permittivity of free space, which is written as epsilon 0. The relation is K equals 1 divided by 4 pi epsilon 0. So the equation becomes F equals 1 divided by 4 pi epsilon 0 multiplied by Q1 times Q2 divided by R squared. The value of epsilon 0 is approximately 8.85 times 10 to the power minus 12 Coulomb squared per Newton meter squared. Force is not just about size, it also has a direction. The force always acts along the line joining the two charges. In vector form, the force on charge 2 due to charge 1 is written as F1, 2 equals 1 divided by 4, pi epsilon 0, multiplied by Q1 times Q2, divided by R squared, multiplied by R hat 1, 2. Here, R hat 1, 2 is a unit vector that points from charge 1 toward charge 2. If the charges are alike, the product Q1 times Q2 is positive and the force is repulsive. If the charges are opposite, the product is negative and the force is attractive. To avoid any sign confusion, many textbooks write Coulomb's law in a slightly different way. They keep the product of the two charges as it is, and they make the unit vector point from the source charge to the test charge. The formula becomes F equals 1 divided by 4 pi epsilon 0 multiplied by Q, 1 times Q2, divided by R squared, multiplied by R hat. Here, R hat is simply a unit vector. It tells us the direction from the source charge to the test charge. The beauty of this form is that the product Q1 times Q2 automatically decides whether the force is attractive or repulsive. If both charges have the same sign, the product is positive, and the force points outward. That means repulsion. If the charges have opposite signs, the product is negative and the force points inward. That means attraction. So far, we assumed the charges are in empty space, but if there is some medium like air, glass, or water between them, the force becomes weaker. This happens because of something called relative permittivity, or dielectric constant, written as epsilon r. In a medium, the permittivity is epsilon equals epsilon r multiplied by epsilon 0. So Coulomb's law in a medium is F equals 1 divided by 4, pi epsilon 0 epsilon r, multiplied by Q1 times Q2, divided by R squared. Since epsilon r is always greater than 1, the force in a medium is always smaller than the force in free space. Because force is proportional to 1 over R squared, if you double the distance, the force becomes 1/4 of its original value. So, doubling the distance makes the force 4 times weaker. Let's solve a quick problem. Suppose Q1 equals 2 times 10 to the power minus 6 coulombs. Q2 equals negative 3 times 10 to the power minus 6 coulombs, 6 coulombs. And the distance R equals 0.05 meters. The formula is F equals 9 times 10 to the power 9 multiplied by the absolute value of Q, 1 times Q2, divided by R squared. First multiply the charges. 2 times 10 to the power minus 6 times 3 times 10 to the power minus 6. 6 equals 6 times 10 to the power minus 12. Now square the distance. 0.05 squared equals 0.02, 0.0025. Divide them. 6 times 10 to the power minus 12 divided by 0.0025 equals 2.4 times 10 to the power minus 9. Now multiply by 9 times 10 to the power minus 9. That equals 21.6 newtons. Because one charge is positive and the other is negative, the force is attractive. Remember, the force on charge 1 due to charge 2 is exactly equal and opposite to the force on charge 2 due to charge 1. This is a direct application of Newton's third law. Coulomb's law says, force equals 1 divided by 4 pi epsilon 0 multiplied by Q 1 times Q2 divided by R squared. Like charges repel, unlike charges attract. The force follows an inverse square law, double the distance, and the force becomes 1/4. In a medium, the force is reduced by the dielectric constant. And finally, the forces between two charges are always equal and opposite.